Good morning to all. So previously we have already studied so many types of chemical reactions, but in class 10 we are going to study majorly only 5 types of chemical reactions. 5 types of chemical reactions. So in that, the first type of chemical reaction which we are going to study in this class is combination reaction. Combination reaction. Second type of reaction which we are going to study in this class is decomposition reaction. The next type of reaction which we are going to study is displacement reaction. And the next type of reaction which we are going to study in this class is double displacement reaction. And the last one is oxidation and reduction reaction. Oxidation and reduction reaction. So, in this class, we will study about combination reactions and the types of combination reactions and the examples for the combination reactions. Combination reaction. So, the first type of reaction which we are going to study is combination reaction. So, combination reaction. Combination reaction means those reactions in which two or more substances combine to form a single substance. Two or more substances to form a single substance is known as combination reaction. Means, what does it mean? It doesn't mean that more than two or more than two substances combine and they will form how many types of products? Only a single product. Only a single product is known as combination reaction. So combination reaction means those reactions in which two or more substances combine to form a single substance are called as combination reactions. Combination reaction. So these combination reactions generally in mathematically will represent with like this: A plus B. Let me assume A is a one substance and B is another substance. These two will react together and they will form a single substance called as AB. This is the mathematical representation or symbolic representation of a chemical equation. Combination reaction. Combination reaction. Now, if you want more informative, it's like a diagrammatic structural way also we can represent the combination reaction in the form of chemistry. That is like that. Let me assume one of the substance which is having a structure of this. The next substance which is having a different other structure will react together and they will form a single substance. How many substances? Single substance is known as combination reactions. Now, let me discuss briefly about combination reactions. In detail, we'll study about the combination reactions. So these combination reactions will be taking place by in three ways, that is either combining by element plus element. Element plus element will combine together and they will form a single substance called as compound. Next type is compound plus compound. One compound will react with another compound and it will form again how many number of products? Only single product. That is called as again compound. And the third type of combination reaction is one element and the second one is compound will react and they will form again how many products? Only single product. Only single product. So whenever you will see a type of any kind of chemical reaction, you can see how many number of reactants, the things which are present before arrow are called as reactants. What we used to call reactant. So how many reactants are involving and how many number of products are coming? Products are coming. So based upon this, whatever the number of reactants must be more than 2. 2 or more than 2. More than 2. But product must be 1. If any kind of chemical reaction which is having only getting one single product, then this reaction will be definitely some type of combination reaction. Now we'll study in detail the examples for the element plus element type of reactions and the compound plus compound type of reactions and the element plus compound or compound plus element type of reactions. So let me start with the first one, element plus element type of reactions. Element plus element type of reaction. So the first example for the element plus element type of reaction, which we have already studied, which we are very well know about that equation, that is, we know that magnesium. So we know a magnesium ribbon, if it will burn in the presence of atmosphere, means oxygen, it will form a compound called as magnesium oxide. Magnesium oxide. So we know that the symbol of magnesium is Mg. Example 1. Example 1. Magnesium will burn in the presence of oxygen. Oxygen symbol is O2 because it is what? Diatomic molecule. Diatomic molecule will react. React means what? It is combination. What is? Combination, and it will form a compound called as magnesium oxide. Magnesium oxide. So the product formed here, see, you can observe how many number of products are coming. Only the single product called as magnesium oxide. So that is why it is called as combination reaction. But if you see here, the reactants, both are elements. See, magnesium is a single element and the oxygen also a single element. So that is why it is an example for both element plus element will react together and they will form compound. It will form compound. So if you'll observe this chemical reaction, we know already you have studied in previous classes, that is, if you'll observe this chemical reaction, you can directly get that it is not balanced. This reaction is called as skeletal equation. So we should balance it immediately. So we can start with the magnesium. So if you'll observe magnesium is balanced because here Mg is equals to, I will explain one, later we can proceed directly. Mg equals to 1. Here also Mg equals to 1. Now let me come to the oxygen. Oxygen here number of 2, but here how many there? 1. So oxygen is imbalanced. So I will balance in the product side by multiplying oxygen with a 2. So that next number of oxygens will become 2. So if number of oxygens will become 2 means number of magnesium atoms also will become 2. But this side number of magnesiums are not balanced. So here till 1. So I will multiply the magnesium with 2. Now you can observe this equation is called as a balanced chemical equation. What we used to call? A balanced chemical equation. So we have already studied how to balance a chemical equation by using a different tricks depending upon the type of chemical reaction. Now, one more thing we have to do for this chemical equation. If you write like this is an ordinance. Means every ordinary people also can write like this. But if you are more knowledgeable, if you want to make more effective, then we have to make this chemical reaction in more effective manner. So how we can make more effective manner? We have already studied how to make a chemical reaction more effectively. So by remembering all the steps, we'll balance and we'll make this equation more informative. So how to make more informative? How to make the given chemical equation in more effective and more informative? That is, the first one is we have to represent the states of given reactant and the products. Given reactants and product. So we already know that. Let me come to this equation. We know that magnesium state is solid state. Which state it is? Solid state. You remember, if you make more informative, then it will be effective. Understood? Magnesium is solid state and oxygen basically which is present in which state? Gaseous state. and this both will combine together, and they will form a solid substance called as magnesium oxide. Magnesium oxide. We'll see this. Now it is a balanced chemical equation, and as well as also it is more effective and informative. And this is the first example for element plus element will combine combination, and they will form a single compound, means it's a product. It is what? Product, and these are called as reactants. Understood? Now let me go for the second example for the element plus element combination reaction. This is also we already know very well, that is formation of water. Formation of water. So we know that water chemical formula is H2O. You remember, water also we can call it as hydrogen oxide. Hydrogen oxide. Now we know that water will form by the combination of two elements. Combination of two elements. They are, one of the substance is oxygen, and the next substance which is involving in the formation of water is hydrogen. Understood? Now immediately if you'll observe, it is not balanced, so I will try to balance directly. You already know that. You try to follow in the same manner. It is already balanced. Now you can observe that one more thing, make it more effective. That is, the hydrogen state is gaseous state, and oxygen state is also a gaseous state, but they will combine together. They will form a liquid substance. So here you also remember three more impacting fact about the reactants and the products. That is, let me come to the first, hydrogen. Hydrogen is highly combustible substance. What does it mean? Combustible substance means it will catch fire easily. Understood? It will explosively, it will burn. Once it will catch fire, it will burn very, very explosively. Means it will release very, very high heat energy. Are you understanding? Now let me come to the oxygen. Oxygen cannot burn. It cannot catch fire, but it will support for burning. It is a supporter of burning. Now see, one of the substance which is involving in the formation of hydrogen oxide is hydrogen, which is highly combustible in nature, and another one is which is a best supporter of burning reactions. But combining of these two, the product which is forming is hydrogen oxide is put out fire. Means it will extinguish the fire. See, completely different properties. That is why it is called as chemical reaction. Means what? Different properties. Before some kind of properties, after reaction some other type of properties. That is why these are called as chemical reactions. Now this is the second example for element plus element will combine, and they will form a single compound or product. Understood? Now the third example, which we already know very well, that is formation of carbon dioxide. Now we know that carbon symbol is C plus will react with what? Oxygen, and they will form combination. You remember, this is what? Combination reaction, and it will form a compound or product called as carbon dioxide. Now I will directly represent the state, means I will make it more effective, more informative by representing the states. You already know that. You also represent. Remember, always carbon state is solid state. Which state? Solid state. Oxygen, we already know that the state of oxygen is always gaseous state, and the product formed by this one solid plus gas is always a gaseous state. This is the third example. Example 3 for element plus element combination reactions of what? The first type is element plus element will give compound, means single compound, single product. Understood? Now the next example, which is the same for the formation of a single product by the combination of element plus element, is hydrogen is reacting with, hydrogen gas is reacting with chlorine. Hydrogen gas is reacting with what? Chlorine. Now we know that hydrogen plus chlorine will react and they will form a well-known compound called as hydrochloric acid. What it is? Hydrochloric acid. So we know that hydrochloric acid formula is HCl, which is basically present in liquid state. You remember this. Here we have to study one more thing very, very important. That is, hydrochloric acid will form by the combination of two substances called as, one is hydrogen, which is a diatomic molecule. You remember here. We should not write that 2H. We always represent based upon the atomicity. Hydrogen is a diatomic molecule, so I will always represent H2, and plus also I can represent that is chlorine, Cl2, Cl2, because chlorine is also diatomic molecule, and they will combine together, combine together. You remember how I am writing more effectively, and they will form hydrochloric acid. Understood? Now I will make more informative. That is, basically hydrogen is present in gaseous state, chlorine also present in gaseous state, and they will combine together and they will form. You remember here it is not balanced. I am balancing now itself. So you can observe now it is balanced. Understood? The product which is forming by the combination of hydrogen plus chlorine is hydrochloric acid, which is also present in gaseous state. Understood? I think by this time one question is rising in your mind, that is, sir, hydrochloric acid will be definitely in the liquid state, but in this reaction it is forming what? Gaseous. Now then why it will be existed in liquid state in laboratory? Because basically the product which is coming in this reaction is present in gaseous state, but we cannot use gas in the chemical reactions. That is why this gas we can dissolve in water. You remember, dissolve in where? Water, and then we will form a liquid hydrochloric acid, which we can represent. We know that already. Any substance, any solution which will form by dissolving in water is called as aqueous state. So that we can represent after dissolving or mixing with the water. Mixing with water. Water means what? H2O. It is called as, it will be converting into aqua form. I think you may clear now. I think your doubt is clear now. Yes, thank you. So one more example which we are going to study for the same kind of, which type of it is? Element plus element will combine. Two or more than two elements will combine and they will form a single product. That is, we already, this equation is also well-known equation for us. That is two substances. One of it is, we know that is sodium. What is? Sodium is a metal, will react with what? The well-known compound which we can eat daily, that is a basic salt which we can eat, that is sodium chloride. So sodium chloride will be formed by two substances called as, one is sodium and the next one is what? Chlorine. Understood? Now let me see, it is not balanced. So I will directly balance here by keeping here and here. Understood? Now I am making more informative. Sodium is present in which state? Basically, it is a metal. So most of the metals are present in solid state. So sodium is present in solid state. Will react with chlorine. Chlorine basically which state? It is present in gaseous state. Basically, chlorine is present in which state? Gaseous state. It is non-metal. Understood? Most of the metals are in solid state and most of the gases are Non-metals are in gaseous state. Fewer exemptions that we have already studied in class 8. Understood? And they will form a compound called as a single substance called as sodium chloride. Sodium chloride. Basically, sodium chloride, which is present in which state? Solid state. Solid state. Are you able to understand? And one more thing you remember here, chlorine is present in yellow color. Yellow color. Understood? Yes. So this is also one of the example for combination reaction of type element plus element. Element plus element. And the next example is example 6. Example 6 is iron. Iron. Iron also we can call as ferrous. Ferrous. Understood? Iron is reacting with sulfur. Is reacting with sulfur, and they will combine. They will combine. Combination. They will combine, and they will form compound. I think you may get by this time, that is iron sulfide. Iron sulfide. FeS. FeS. Now represent the state of these elements, reactants and products. Iron is present in solid state. Sulfur also present in solid state. Sulfur also will present in solid state. And FeS, the product which is forming by the combination of iron plus sulfur, is also which is present in solid state. Also present in solid state. Understood? So these are all the examples for element plus element of type of combination reactions. Understood? Now we are going to study two compounds will react together and they will form again a single product. Single product. The second type of combination reaction is two compounds. Compound plus compound will react together, means combine, combination, and again they will form a single product called as compound only. Understood? You remember, always in combination reaction will never form elements. Always it will form compound, because always it is how many number of products? Single product. One product. Understood? Now the second type of combination reaction is compound plus compound will react together and they will form again what? A product, single product called as compound only. So the first example for the combination reactions of type compound plus compound is calcium oxide. The well-known equation, the well-known compound which we already know that is calcium oxide will react with water. Means it will react with what? Water. I think by this time we may get the compound, means product, that is calcium oxide will dissolve in water, will form, definitely it is calcium hydroxide. Calcium hydroxide, CaOH twice. Understood? We know that calcium oxide also we can call as lime. What we can call? Lime. Or also we can call as quicklime. You remember, quicklime. Understood? And we know that a state of calcium oxide is solid state, and the state of water is which state? Liquid state. And the state of calcium hydroxide is again in solid state. Solid state. So this calcium hydroxide also we can call as slake lime. Slake lime. Slake lime. You also remember, when it is in liquid state, when it is in liquid state, we can also say this is called as lime water. What we can call? Lime water formula is also calcium, CaOH twice. CaOH twice. Are you able to understanding? Now this is the first example for a type of combination reaction which is forming a single product by combining of two compounds. Two compounds. Compound plus compound is reacting and again they are forming a single product. Single product means here what it is? Combination. Combination. You remember how I am writing. How I am writing more effectively. You have to write this same thing. Understood? So now we will study one more interesting fact which we are using which we are observing in daily life about calcium hydroxide. calcium hydroxide. So we know that everybody will, let me discuss in detail about this calcium hydroxide. What I am saying you that we can see that every houses, most of the houses, we can do whitewashing. Have you heard that? Whitewashing. Whitewashing means a white paint we can make a brushing with for all kind of walls. Whitewashing means white paint. White paint. You can observe that a painter, once he will come for the painting to your walls, house walls, he can dissolve some kind of white powder in water and he will brush to the walls. He will brush to the walls. That is calcium hydroxide only. Calcium hydroxide only. So this calcium hydroxide will never form directly. We know that calcium hydroxide will form basically will be by combining of calcium oxide with water, and they will form calcium hydroxide. Calcium hydroxide. Now, normally what I am saying here, it is in solid state. When it will become dry. But if you want to apply to the walls, it must be in which state? Liquid state. Liquid state. But here, see, this is dissolving in water. So if something is dissolving in water and they are forming solution, means it is in which state? Aqueous state. What we can call aqueous state. Now, this aqueous state of calcium hydroxide will react with water. React with carbon dioxide. Means after applying the walls, now I will take the calcium oxide and I will dissolve in water. I will take the brush and I will apply to the walls. Now, this calcium hydroxide will be in wet because it is in aqueous state. Now, once after applying to the walls with the help of brush, now this calcium hydroxide will react with the carbon dioxide which is present in atmosphere. In which state? Gaseous state, and they will form a compound called as stable compound called as calcium carbonate, CaCO3. Yes, and also one more product it will form is again water. What it is? What? This water will evaporate. Now, after drying of this calcium hydroxide, which we can see after painting of 2 or 3 days, we can observe that a solid, like a slate, small plates. It's like a small, thick, so very less thick plates. That is calcium carbonate. You remember very important name. The another name, general name of calcium carbonate, scientific name of CaCO3 is calcium carbonate, and the general name is limestone. What is limestone? Why it is called as limestone? Because by dissolving CaCO3 powder in water, again we can form CaO, calcium oxide. Understood? That is why it is called as limestone. That we will study in the second type of chemical reactions, that is decomposition reaction. Now, this is the first example for compound plus compound will react together and they will form single product. Now, the second example for the compound plus compound of a combination reaction is ammonia. We know that ammonia formula is NH3. Will react with hydrochloric acid, and they will form, what they will form? Ammonia will react with hydrochloric acid and they will form ammonium chloride. What they will form? Ammonium chloride, NH4Cl. Now you can observe here, I think it is balanced. Yes, it is balanced. Now let me go for more informative, that is combination. Ammonia is state in which state? Gaseous state. Hydrochloric acid also will be present in which state? Gaseous state. And also the product which is present in not in gaseous state, it will be present in solid state. Or it is solid state. So the compound name is what? Ammonium chloride. Ammonium. Remember, ammonium, CHLORID, ammonium chloride. Remember, ammonia, NIA, ammonia, AMMONI, ammonia, NH3, ammonium, ammonium, NH4, NH4. That is why I am writing here UM. Understood? Understood? These are the examples for compound plus compound of combination reactions. Combination reactions. Now we'll go for the third type of combination reaction, that is one compound will react with element, or element will react with compound, and they will form again how many number of products? Again a single product, that is again called as what? Compound only. It is called what? Compound only. Understood? Now see the example for the element plus compound of combination reaction is, the first example is carbon monoxide. Carbon monoxide. You know that the formula is CO. Will be reacting with oxygen. Will reacting with oxygen, and they will form combination. Understood? And they will form, I think we may get the product that is called as carbon dioxide. Carbon dioxide. And represent the state of these substances. Carbon monoxide will be present in gaseous state. Oxygen also present in which state? Gaseous state. And carbon dioxide is also present in which state? Gaseous state. Now need to balance it. I think now it is balanced. Now it is balanced. So this is the example for what? Compound plus element will react together and they will form single product. Also we can call it as is compound only. It's compound only. So one more example for the compound plus element or element plus compound is oxygen will react with sulfur dioxide. You remember sulfur dioxide, and they will form sulfur trioxide, SO3. SO3. So now here I think we have to balance it. 2SO2. O2 plus 2SO2. Here if I will keep 2, then everything is balanced, and all the states is also will be here in which state? Gaseous state. Also it will be in which state? Gaseous state. Understanding? So these are the different types of combination reactions and different examples for element plus element, compound plus compound, or compound plus element, or element plus compound type of combination reactions. And the one more very important point and very interesting about combination reactions is, you remember, this is the most important thing, that is combination reaction means you immediately have to remember one point, that is more than two or more than two reactants. 2 or more than 2 reactants will react and they will form how many number of products? Single product. Reactants must be 2 or more. 2 or more, but product must be 1. And the second is, you remember, very important for the all type of competitive exams and board exams, that is most of the chemical reactions of combination. Remember, most of the combination reactions are exothermic reactions. Exothermic reactions means, we know that exothermic means they will release, means after the reaction, means once the reaction will takes place, they will release the excess heat energy. So most of the, I am not saying that every combination reaction is not exothermic reaction, but every exothermic reaction is combination reaction. So not 100%, 100 reactions, every reaction is not a combination reaction. Few reactions are, remember, endothermic also. The best example for the combination reaction which is not exothermic. Understood? All the combination reactions are exothermic reactions. Understood? Most of the combination reactions are exothermic reactions, but not all. Few reactions, like suppose nitrogen will react with oxygen and they will form a oxide called as nitrogen oxide. Nitrogen oxide balancing. Understood? Gaseous state, gaseous state, gaseous state. If you want to form nitrogen oxide by the combination of oxygen and nitrogen, you have to heat. Means you have to add the heat energy. You have to increase the heat energy. You have to increase the heat energy. Means what? You have to provide the external heat energy. That is why, see, even though it is a example for combination reactions of type element plus element, it is not exothermic reaction. It is not exothermic reaction because we have to provide heat energy. We have to provide heat energy. So from this we can conclude that all the exothermic reactions are combination reactions, but not all the combination reactions are exothermic, but most of the combination reactions are exothermic reactions. Most of the combination reactions are exothermic reactions. So with this, today's class I'm going to end, and next class we are going to study the second type of chemical reactions called as decomposition reactions. Thank you.